Hello everyone, welcome to my channel. In this video, we will learn about the traveling salesman problem using the dynamic programming approach. The traveling salesman problem is a classic optimization problem where you want to find the shortest possible route that visits each city exactly once and returns to the starting city. While there is no polynomial time solution for the general traveling salesman problem, we can utilize the dynamic programming approach that works well for smaller sized problems. So how do we define the subproblems here in the traveling salesman problem? So imagine you are at a particular city and have already visited some other cities. The subproblem becomes what is the shortest route visiting all remaining cities exactly once, starting from the current city and returning to it. So here, we are going to start from a particular city and visit nearby cities, and then again reach the starting source. We have to reach the source. So we have to start from the source and visit all the cities nearby, and again revisit the source after reaching the neighboring cities. So this is the problem in the traveling salesman problem. So this is the formula: g of I comma s equals to minimum of k belongs to s subset, and here the c is the cost from the node I to the k. So here the k is a subproblem. So we have listed the I here, and we need to calculate the cost from the I to the k, that is a subproblem. And then again we need to find the path from the k to the remaining number of nodes. Okay, that is the subproblem to the remaining cities. Okay, so this is the meaning of this formula. So now let us solve a simple problem here based on this traveling salesman problem. And so before going to solve this problem based on this formula, so if you observe, this formula is recursive. Okay, so here we solve this minimum of Cik and g of k comma s minus k. So this is a recursive one, so it will again be repeating. So this is the problem given, and we need to find the minimum cost starting from the initial node to the remaining nodes. So first we are going to start from the initial node, that is 1, and we need to visit the remaining set of nodes, that is s. 2, 3, 4, that equals to minimum k belongs to what is the s, that is the remaining nodes that we have to visit. So 2 comma 3 comma 4 of, and the cost of reaching from the 1 to the remaining nodes, 1 to the kth node, that is c 1k plus g of k comma 2 comma 3 comma 4 minus k. Okay, so this is the formula for the traveling salesperson problem. So we will solve this one graphically here. So we will start from the initial node is 1. So from 1, so where can we travel here? So from 1 we can travel 2, 3 and 4. So this is the bidirectional graph, right? We can travel from 1 to 2, 3 and 4. Okay, so we are selecting the possible ways here. Okay, so we can travel to 2, 3 and we can reach 4 also. From 1 we can travel to these neighboring cities 2, 3 and 4. Okay, so next from 2, so where can we travel? So we can from 2, so we have already visited 1, then what is the possibility here? So from 2 we can visit 3 and 4 nodes. So 3 and 4 nodes we can travel. Okay, so we can travel from 3 and 4 nodes. Similarly from 3, so here 1 is already visited, so we can reach 2 and 4 nodes. And similarly for 4, so we have already visited 1, so we can reach from 4, 2 and 3. We can visit 2 and 3 nodes. Okay, so first of all write the formula here for the node 2. So what is the node 2 value here? So we have traveled from the source, that is 1, to the subset, the sub problem here, to 2. So source to the sub problem here, and then plus g of 2 comma 3 comma 4. That means we have already visited 2 and we need to visit 3 comma 4. We can visit the either 3 or 4 from the 2. Okay. So similarly here, so we have already visited from 1 to 3, we have traveled already, and we need to travel from 3 to remaining nodes. So g of 3 comma, what are the remaining nodes here? 2 comma 4. Okay. So here also, so we have started from 1 to 4, travel from 1 to 4. Now we need to travel from 4 to the remaining nodes. So what are the remaining nodes here? 2 comma 3. Okay. So like this we have written this recursive formula. So now we will select the 2 paths here. So from 2 we can travel 3 and 4. So 3 and 4. So we will solve this formula later. Okay, 3 comma 4. Okay, and from here we can travel to 2 and 4. From here we can travel to 2 and 3. Okay, so these are the possible paths. Now from 3 we will check here. So from 3 where can we, so we have started from 2 and reached 3. Okay, so from 3 we can travel to 4, right? So that is C of 2 to 3. So we have traveled from 2 to 3. Next we can visit, from 3 we can visit the next possible node is 4. Okay, C2 3 comma plus G of 3 comma 4. Similarly here, so we have started from 2 and we reached 4. So C2 4 plus G of, so from 4 what is the next remaining node? 3, right? So remaining node to travel is 4 comma 3. So from 4 we can reach 3. So similarly here for 2 we are going to write down. So from 3 we have traveled to 2. So C32 plus G of, so from 2 where can we visit? The next visitable node is 4. So G of 2 comma 4, right? So here also, so from 3 to 4 we have traveled. So we need to find out G of 4 to 2. So which is the unvisited node? 2 is the unvisited node. So here also, so we have revisited the 4 node, 4 to 2. So C 4 to plus G of 2 to 3, because 2 is the visited node and 3 is the unvisited node. So next for 3, so C of 4 to 3, 4 3 plus G of, so G of 3 comma 2. Okay, so these are the formulas that we have written for each and every node. So here the 3 is the visited node and 4 is the next next node that we are going to visit. Similarly here 4 is the visited node and 3 is the next node that we are going to visit. Okay, so now next, so we from 3 we have to visit node 4, right? So from 3 we can reach the node 4. Okay, so from node 4, so for this node we have to calculate the formula. So C 3 to 4 we have visited and G of 4 comma, so there is no node, right? So again we have to visit the 1. So in the traveling salesman problem, so we have to start from the source city and visit all the nearby cities and again reach the source city. Okay, so for after reaching all the nearby cities, again we have to reach the 1. Okay, so we are we are not mentioning that one here. So 4 comma null we are writing. Okay, so here the null means next we have to visit the neighboring node 1, right? So similarly here also 3, right? So C 4 3 plus G of 3 comma null. Okay, next node is 4 and C of 2 4 plus G of 4 comma null. So from 4 there is no way to traverse the remaining nodes. So since all the nodes are visited, and here also C 4 to 2 4 2 plus G of 2 comma null, and here also so 4 2 3, so C 2 3 plus G of 3 comma null. So here also we have 3 to 2, and this is written as C 3 2 plus G of 2 comma null. Okay, so these are the values written. So we know that in dynamic programming approach we solve the problem in the reverse approach. So it is a reverse approach. Normally in greedy in dynamic divide and conquer method, so we will solve in the top down approach, but here we will solve bottom up approach. So we will solve the sub problems and then we will find the remaining sub problems. Here we will find the minimum of the sub problems and then we will solve the entire problem. So here, so what is the cost of 3 to 4? So here the cost of 3 to 4 is given as, so 3 to 4 is 12. Okay, cost of 3 to 4 is 12 plus G of 4 to null. So 4 to null means, here null means, so we have to remember that, so after visiting all the neighboring nodes here from 1 to the neighboring nodes, so next we have to reach the source city. Okay, so for all these one, the value will be 1 only. The null means 1. Okay, so 12 plus 4 to null. 4 to null, that is 8. So 4 to 1, here 4 to 1 value is 8. So 8. So 12 plus 8. Okay, so next C 4 3. So what is the 4 3 value here? So 4 3 is 9. So 4 3 value is 9 plus G of 3 to 1. So 3 to 1 value is 6. So similarly here C 2 4. So 2 to 4 value is 10. So 2 to 4 is 10 plus G of 4 to null. So 4 to 1, right? So here null means 1. So 4 to 1 means 8. 10 plus 8. Next C 4 2. So C 4 2 means 8 plus G of 2 to 1. So 2 to 1 value here is 5. Next C 2 3. So what is the 2 3 value? 9, and 3 to 1 is 6, and here 3 2 is 13 and G of 2 to 1 is 5. Okay, so we have to perform the sum here. Okay, so 12 plus 8. So 12 plus 8 is 20, 9 plus 6 15, 18, 13, and 9 plus 6 15, and then 13 plus 5 18. Okay, next we will go the next level. Okay, so we'll go to the next level. So this is a recursive approach, right? So this value is for the G. So 3 to 4 is 20. The weight of 3 to 4 is 20, and 4 to 3 is 15, and 2 to 4 is 18 here. 4 to 2 is 13, and 2 to 3 is 15, and 3 to 2 is 18. Okay, so now we have to add this with the cost of 2 to 3 value. So what is the cost of 2 to 3? So cost of 2 to 3 is 9. So 9. So 20 plus 9, that is 29. Okay, and cost of 2 to 4, that is 10. Okay, 10 plus 15 is 25. So similarly here cost of 3 to 2. 3 to 2 is 13, and cost of 3 to 4 is 12, and then cost of 4 to 2 is 8 and cost of 4 to 3 is 9. Okay, so now we will perform the sum of these values. So 13 plus 18, that is 31, and 12 plus 13. So here now we find out the values after obtaining the sum with the cost. So now we need to find so we have two values here. For the 2 we have 3 and 4, for 3 2 and 4, and for 4 2 and 3. So we need to find the minimum of these two values. So what is the minimum of these two values? 29 and 25 is 25. Sorry, we had to write here 25. Okay, and 31 and 25, 25, and 23 and 27 is 23. So these are the minimum values. So we need to add these minimum values with the cost of the neighboring values. So cost of 1 to 2 is 10, and 1 to 3 is 15, and 1 to 4 is 20. So we need to perform the sum here. So what is the sum? 25 plus 10, 35, and 25 plus 15, 40, and then 23 plus 20, 43. Okay, so from these three values, what is the minimum value? Minimum value is 35. Okay, so we got the minimum value here. So through this minimum value we can reach all the cities, the neighboring cities. Okay, so from 1 to 2, so the minimum path here is, so the minimum cost here is from 1 to the remaining nodes is 35. So this is about the traveling salesman problem. Thanks for watching my video.